Just two guys braiding.
Welcome back to the electric Land Cruiser. Today we're going to go back to the build videos and we're going to install the high voltage wiring. So we're going to make up the high voltage cables, put the lugs on them, wire them into the truck and protect them from any sort of damage. We'll also check out the controls, the park, neutral, and reverse buttons, and some of the 3D printing that we did for that. So let's get started. All right, so today's the day that I want to finalize all of the wiring in the Land Cruiser because I've got another battery. Look at that, from a 2015 Leaf this time. Got it cheap on Copart. Tore the car apart in a day by myself. Got the motor and the battery pack out of it. So I don't know if I want to use this one as my final pack in the Land Cruiser. Like I said before, I'm really holding out for that 2017 Leaf 30 kilowatt hour battery because that's going to be basically my highest capacity option. You know, it's the newest battery, so it has less years of degradation on it, and it's 30 kilowatt hour battery, which is the highest that you can get in the 13 to 17 Leaf, which is what the Resolve controller and what all these parts that I'm installing in the car are for. So I have to stick with that battery for the moment, at least. And also the cost, I could probably get, you know, I think there's a 40 and 62 kilowatt hour battery for the later Leafs. They're just more expensive, you know, so this is in my budget. All right, so for today, what I need to do is finish up just a couple grounds here, get a couple of the relays dialed in, buttoned up, and then the elephant in the room, the high voltage, high current wires that I'm gonna have to make from the inverter, or I'm sorry, the power supply to the inverter, and then from the inverter down to the motor. Now, originally these are like bus bar style, that these slot into the slots on the inverter and then the motor, and they're three stacked on top of each other. And then you put a bolt through there and tighten them up, and that's how the connection's made. But since I had to split these apart just for packaging, what I'm gonna have to do is create connectors, lug connectors, and wires. So then I've got heavy gauge cable. I got like some 0 gauge, 1/0 stuff, like high quality. So what we're gonna do is make the battery wires out of these, or make the motor, high voltage motor and inverter wires out of those. And then also, just to show you what the lugs look like. So here's the motor, and so in there, those are the 3 connectors for the inverter, and you can see how they're just a slot type. And then here, this panel comes off, and here, I'll do it. Okay, so then that panel comes off, and those are the 3 lugs there. So, all right, so I'm working on the big gauge cables here, and what I've got is these big 0 gauge cables, and I put these big lugs on them that what I'll do is bolt onto those 2 terminals there. I got this huge sheath, and then also I got some orange tape for high voltage, because on EVs the standard is all the high voltage stuff is orange. So I don't know if I have enough, but I'm going to make sure that these are all orange all over and protected, very well protected with this couple layers of tape insulation, so no matter what, they will not short or anything. Let's get to it. Okay, here are my main DC wires that go from the power supply to the inverter. So these supply the full 400 volts, 200 amp current. And yep, there we go. The next one we'll do is the 3-phase that goes from the inverter to the motor.
My drive shaft. I gotta leave right now to go there before they close. Hell yeah.
Just two guys braiding.
Yep. Just some Friday night braid. Braiding party. Yay. Yeah, of course you do the same way, so you agree. Oh, shit. Braid fail.
Sweet. Take some to the next
Yeah, looks like you can kick the shit out of somebody with it.
Sweet. Okay. So here I'm going to cut this. Well, we don't need to cut it right now.
Oh, you know what sucks though? You didn't identify each one.
I did.
Oh, you did?
Yeah.
Oh, look at you. You're smart, dude. And I'm the licensed
I've done that before, man.
Now I gotta redo it.
Well, here, let's wheel the motor over so we can mock it up.
Okay.
All right, we're doing the high voltage wiring on the inverter. I'll show you what I'm up to. So I've just put these lugs on the wires. I also numbered them so that I would know which side's which. And basically these lugs are fitting nice and snugly in this factory leaf slots you can see in there. You can see in there where the lugs are connected to the bus bar, and then the bolt goes through and secures them, so that's nice and tight. I'm really happy with how that turns out. So what I'm going to do is pot this area with silicone. I have a 3D printed design for this to plug this area here because it's a little bit more open, but on the inverter I think I'm just going to pot this area with silicone to keep the weather out of it, and secure those wires. Don't need too much support because they're really nice and secure, bolted on. So that's what I'll do on the inverter, or I'm sorry, the charger on the inverter. Same sort of thing. These three are going to bolt on those three locations. What I'm worried about though is that these aren't supported and they're just hanging out here in the breeze. So like with this heavy wire bolted on there, because a lot of torque, a lot of force on these bus bars and break them off or damage them or you know, down the road. So what I'm doing is I'm 3D printing as we speak a nice little plug that'll slide over here, and it will support these on either side with plastic, ABS plastic. It'll fill up this area here, and I can use some silicone to seal it, and then it will have some gaps for the lugs to bolt on, and then everything will be nice and supported that way. So that's the plan with the inverter, and then down on the motor, I'm hoping what I can do is just stick the lugs down and bolt them in like I did on the charger. So that is what I'm hoping I can do on the motor. But yeah, we're just plugging away, getting the final touches done on the wiring for the old electric Land Cruiser. Man, we are seriously close to testing it for the first time. Oh man, still tons of work left to actually make it like a battery operated electric vehicle, you know, because there's no battery in it. But we're really close to testing the systems, testing the motor and everything. So yeah, let's get on with it. All right, man, this is such a cool moment. I got the motor stuck in, now supported by the chassis of the vehicle. There's nothing underneath it. I didn't film a lot of it, just wanted to get through it, but I'll show you what I was doing. So this is that mount that I made, and then this is just a piece of box steel, and I've cut or drilled holes in it so that I can fit bolts and nuts down there. I only have 4 in. The 2 middle ones are going to take some finagling to get around the drive shaft, so I'm going to leave those until the final install because I still have to paint this and everything and finish the welding on all this stuff. But the drive shaft is pretty straight. I need to make another mount for the rear of the transfer case too. So I think when I do that, it's going to straighten it out some more. But the way that I drilled all these holes on the front and the back, I can have a little bit of movement to shift the motor to get exactly how I want it to be, because this needs to spin smooth, or otherwise I'm going to have problems. If this isn't smooth, it's going to cause huge vibration issues and stuff like that. And then the front mount just comes off this stock motor mount. I'm going to tie into this corner here too, onto this piece of angle steel here that I just right now is just tacked in there, but tacked in good enough to hold the motor for now. So I'll be able to put this up on the lift, I think, and then I'll get my transfer case exactly where I want it. But this is a big moment where the motor is now in the car, in the truck all by itself, and pretty much exactly where I want it to be. So this is really cool. We'll keep moving ahead. Can't wait to drive this thing. It's gonna be so cool. All right, so we're here looking at the inverter, and these are the 3 wires that go to the motor. These bus bars are kind of hanging out here in the wind, because normally on the stack, you have to get the charger, the inverter, and the motor in the bottom, so they all plug into each other vertically. But what I've got is I've got these lug terminals that I want to put on there, but I don't want to just bolt them on there, have these out in the breeze, because then, you know, it could, these could break or crack over time. They could get bent out of their position and touch each other and short out or something. So what I did is I 3D printed this little guy that fits over here, and it will slide down on there into that cavity and take up all that space. And then this is solid ABS plastic, so it's really strong. And what I'll do is put this on here with some sealant to seal it up against the elements, and then that way I can bolt these on, and these lugs will be nice and supported all the way around. And then I've got some little tabs on here, because what I'll do is I'll put, I think, some conduit and some heat shrink over the top of everything, just for extra protection. So we'll go ahead, I'll put this on and we'll start hooking up the wires. Wow. Wow, that actually fit better than I expected. It's nice and flush along here. Looks like we've got the right distance for our lug terminals. Yep. To bolt on. Pretty well supported. Looks good. I'm gonna smear the sealant around there and I'm gonna get ready to bolt up the lug terminals. All right, so go ahead and bolt these on. I put some conductive paste on there. Gravity. So I'll make sure that we get this right so that we don't have to do it again. Is 1, 2, 3. Okay, so now I've got them labeled. What I'm going to try to do is got heat shrink for each one. Sorry, I keep wired up enough motors the wrong way that I know to check when I'm not sure. All right. All these bolts I've so far harvested off the Nissan Leaf. Just trying to recycle as much as I can from that car. So I decided what I'm going to do is put 2 on top and 1 below to try to distribute the force both directions. Feed this down here. Where it's gonna live. These were going to interfere with the heat shrink anyway, so make sure this is straight. All right, so I got the motor wires here. Like I've labeled 321, because on the other side on the inverter, they're 1, 2, 3, and the inverter and the motor are 90 degrees from how they were in the leaf. So I'm gonna put some conductive paste on these guys. Double check, 1, 2, 3, 3, 2, 1. We'll stick these in there. It's actually super convenient how well these lugs fit in. I probably don't need that. Awesome. Alright, super cool. We got those hooked in, so now we've got the motor wires from the inverter. Let's see where they go up there. All the way here to the motor. And we got 3, 2, 1 there, and 1, 2, 3 here. Because it's 1, 2, 3 coming out of the inverter, and then we need to rotate it 90 to 3, 2, 1 because they're 90 degrees from how they originally were. So that's how it is. Man, that is great. Look at that. So what I'll do is tuck this up somehow and mount it to the firewall so that it stays undamaged and protected from anything. There's our 3 lugs. Happy as can be. Good separation between them. And I'll pot all this area with silicone, again like I did with the others. All right, so now we got the motor hooked up. We're gonna hook up the main 12 volt or 400 volt DC from the PDM to the inverter. So that's these 2 lugs here. And I just 100% triple checked, 4 times that these were all correct because I do not want to hook up it backwards. So as usual, we'll put some conductive paste on. How's this going to be the most copacetic? Trying to think of how I want to actually do this. under actually. Maximum separation. Very cool. So I'm going to go ahead and cover those in tape and conduit, and then that high voltage cable will have to secure up against the firewall somehow. I've got some big P clamps that'll probably be good for that. It's coming together. one of the things that's really cool about the Resolve EV controller is that it allows you to maintain the OBD2 connector and run the EVSwap app, which is a very cool app that is third party. It's not by Nissan, it's by a third party. You can read the battery stats, you know, each individual cell, their exact voltage, and you can see the overall voltage, state of charge. You can see how many charge cycles have been on the battery, both quick charges and normal L2 charges. It just shows you tons of information, and I'm going to be able to get all that in my custom EV. And once more, I'll be able to put a like tablet or something and have that display and have just more information, which is going to be cool because it'll show me power consumption too, like power and regen. So I've got the OBD2 plug from the Land Cruiser, and now I'm going to pin it out so that we have these 4 pin connections in the correct spots. There's a couple of them that I need to move around, so I'm going to go ahead and do that. Alright, that's all there is to it. I got my 4 connections for my 4 pins. I might have to add another ground, we'll see. But I only have 1 ground because I had to use the other wire in another spot, but we'll see. Alright, let's wire that in. Alright, now for my drive, neutral, and reverse buttons, I got these cool stainless steel momentary push buttons. So they're pretty cool. I only need 3 of them, but I had to buy 4. So I'll get the 3 best ones. And this is just a momentary push button that there's no connection, and then when you push on it there's a connection, but then when you release there's no connection again. And these are how you shift the inverter and the motor from drive, neutral, and reverse. So these get wired into the Resolve controller, you know, just like that, and that's how you shift. So I'm going to go ahead and put these in the custom 3D printed panel that is should be coming off the printer here in just a couple hours, but I'm going to go ahead and start wiring these in so that it'll be ready. And that's one of the coolest parts. I'm so jazzed about being able to do that, because a lot of people think, how do you put the truck in reverse, or if something goes wrong with the electronics, how do you put it in neutral? Well, it's digital. It's all digital with a modern brushless motor. So you just push a button, tell it you want to go backwards, and it goes backwards. Makes sense, right? Let's do it. Alright, so I got some little spade connectors soldered onto each switch. I decided to do that instead of these little screws that come with the switches. Just didn't want to do that. And then I used, again, some of that high quality USB extension cable I had. And I got the 3 ends here. Blue is go. Black is neutral, and orange or red is reverse. So I've got those 3 marked, and then they go to the harness also. So I've got that all done. Now I just need to put them into the truck. 3D printers, man, If you've got a 3D printer I've used with them, you know it's a love-hate relationship. The print was only supposed to take 2 hours, but it's like 6 hours later and I'm waiting on like the third try, so we're gonna give it another try. I like redialed in my whole 3D printer, recalibrated or reset the height on all the corners, and it's actually printing really well, so we're gonna hopefully get a good result here shortly. And then we'll put it in the truck. All right, so we're here in the print shop and I got a couple first prints. So this is my drive reverse or neutral and reverse button switch panel, and then these two are going to be for my center diff lock, and I think a disconnect for my brake input to the resolve so that you can use left foot braking. And then this is a little mount for my OLED screen. So let's do a little test fit here. First, the OLED. So normally there's a little clock here next to the vent. This says EVSwap, but I need to do that model again and probably a little bit bigger font. So it lines up okay, but it's not. There's a couple gaps in the top and bottom. Side to side it looks pretty good. Does a pretty good fit to side to side. Looks like all 4 of the screw holes line up. So really you just need to narrow the top and bottom of the screen, like maybe a millimeter or so. Let's see if it fits. I don't have my screws. But so there's 2 mount holes there, and I just tied off those, the same as the clock. Oh, that looks cool. Nice, look at that. Yeah, I need to adjust it a little bit. It's not, but it's pretty good. Looks pretty good, I think. Okay, good first test. Version 1. It's always nice when the version 1 is at least somewhat usable in 3D print. Okay, so this is the center console area. And then this panel is going to fit here. Alright, I think I got us there. Some tabs I'm trying to pull in on the inside. Well, it sort of fits. It looks pretty good. I need to tighten it up on the bottom and round the corners a little bit more. Otherwise, I think that's going to work. I'll show you on the inside. So I'm trying to grab on this ridge that goes around. That's really the only thing I got to locate it. Yeah. It grabs it and it rests over here, and what I'll use is some glue or something. Not much I can do. I can use screws and stuff, but then there'd be bolt holes sticking out of here, and I don't think it would be very secure anyway. I think glue would be better. But I like it. Good first try. Alright, next time it'll work. Alright, thanks again for watching the electric Land Cruiser. Be sure to subscribe and tell your friends. Hit the like button, and we'll see you in the next video.